Hey everyone, as promised, I'll go through the example where we have hx over gx, but it's going to involve partial fractions, right? So let's put up an example, 1 over x squared plus 3x plus 2 dx, okay? So clearly you can't integrate this directly, and you could opt to convert it to the form of 1 over x squared plus a squared over x squared plus minus a squared. But this is not what we actually want to do here, alright? Instead, what we can choose to do is to use it in partial fractions. So we notice that are we able to factorize the denominator? Answer is yes, because if we were to factorize it, we'll get x plus 2 and x plus 1 dx. Therefore, we can then break it down to two fractions. So what I do is I'll put the x plus 1 here, then I'll put the x plus 2 here. Reason being is that because I'm going to cross multiply the fractions, I want the fraction the higher constant on the right, so that because I'm going to times x plus 2 here, and I'm going to times x plus 1 here, it's likely that, well, x plus 2 is larger than x plus 1. So I'm going to times x plus 2 here, and then going to times x plus 1 here. So it's clear that, well, it's going to be 1 over 1. Why is that so? Because I'm going to times x plus 2 here, I'll minus x minus 1, so x minus x gives me back 0, 2 minus 1 gives me back 1, which is all I need. So that would be the final fractions form. So this is how I do partial fractions really quickly. So I end up getting 1 over x plus 1 minus 1 over x plus 2. Now I just integrate, then I realize I get ln x plus 1 minus ln x plus 2 plus c. I'll then end up having ln x plus 1 over x plus 2 plus c. Obviously, you can do it the other way around. You can do it another way. So you can have x plus 3 over 2 square, and you end up getting minus 1/4, because 3 over 2 square is 9 over 4. You only have 2 here. So 9 over 4 is 2 and 1/4, so I have to minus by another 1/4 dx. Then this would be the 1 over 2a form, right? So a is half, right? Because 1/4 is a square, so a is half. So 1 over 2 times half is 1, so I can ignore that. Ln x minus a, so I have x plus 3 over 2 minus half, so it gives me back x minus, so x plus 1, yep. Then x plus a, so x plus 3 over 2 plus half, so I get x plus 2. Then obviously I mod it, then plus c. Alright, so either way works, it doesn't matter what you're going to do. Okay. Another example, this time is quite different. We have x squared over x squared minus 2x plus 3 dx. Okay. So first thing first, we long divide, right? And after we long divide, actually it's quite obvious now, it's just simply 2x minus 3, x squared minus 2x plus 3, of course with the 1 plus. How do I do it very fast? So I go through my head, well, long divisions, this is literally what happens in my head. So x squared divided by x squared minus 2x plus 3, right? So clearly it's going to be 1, right? Then I'm going to minus x squared minus 2x plus 3. Because there's a minus sign outside, I'm left with 2x minus 3 inside. Okay, so that's how I do a long division. Nonetheless, this is the derivative that you're going to get. 1 plus 2x minus 3 over x squared minus 2x plus 3 dx. So 1 becomes x, that one's pretty obvious. But what about the denominator? Okay, so again, are you able to find a way to do partial fractions? So answer is no, right? Because you have 3 and 1, and both of them are either positive because here's a positive sign, otherwise you only have minus 3 and minus 1. This will give me 4, this will give me minus 4. Therefore, I can't get minus 2, so there is no way for me to do partial fractions in this integral. So I have to do the normal way, right? So I have to find it to a ln form. So to find it to a ln form, I realize this gives me 2x minus 2. So I get 2x minus 2, x squared minus 2x plus 3, because just nice my numerator also has a constant, a coefficient 2 in the x term. Then minus again, because I have 2x minus 2 here, I need to minus another 1 to get 2x minus 3. Minus away 1 over 2x. 1 over x squared minus 2x plus 3. And I think here you can just solve it by yourself, so I'm just gonna proceed on. So I get ln x squared minus 2x plus 3 minus away this, if I'm not mistaken, it should be of the form 1 over root 2 tangent inverse x minus 1 over root 2. Okay, I'm going to do this in my head, that's not bad, because this is basically 1 over x minus 1 square plus 2. Yep. Alright, so do take note that sometimes you're able to do partial fractions, sometimes not really. But if I will do partial fractions, you should aim to use partial fractions. Otherwise, really you can just convert it to this form or this form, anything goes.